Good afternoon, everyone. This is S. Janvi. I'm from CSE second year studying in Srinivasa Ramanujan Institute of Technology. And for CA assignment 2, my topic is graph coloring. So first, let's look at the outline. Includes the topics that I'm going to cover in this presentation. First, I'm going to start with the introduction. Then we will look at the key terms in graph coloring and algorithms that are used in the graph coloring, and we'll get to know what is the chromatic number and the applications where we can use this graph coloring method. And we will take a sample problem and see how this graph coloring is basically done step by step. So first, so in the introduction, I have basically given the definition of graph coloring and the basic terms. So first, let's know what is graph coloring. So it is the way of assigning colors to vertices so that no two adjacent vertices share the same color. And the objective of this graph coloring is basically to minimize the number of colors used, and this term is known as chromatic number. So when we look at the diagram that I have given here, it basically represents that the no two adjacent vertices have same color. Since here you can see that it is blue and pink, and next adjacent vertex is white. Likewise, we have to color the graph on the condition that no two vertices should be of same color, adjacent vertices. Next, when we look at the basic requirement, that is uh, the condition itself is the basic requirement here. And the applications, this graph coloring is widely used in scheduling, frequency assignment, and resource management. And it actually ensures efficient conflict-free assignments in various fields. Now we'll get to know the key terms in graph coloring, that are the basic terms that we need to understand what is a graph coloring. So we have first is the vertex. So a vertex is basically a node in a graph, and the edge is the connection between two vertices, basically a line that connects the two vertices. And the adjacent vertices means the vertices that are connected by an edge. And the condition in graph coloring that the no two adjacent vertices should have the same color. And the chromatic number, we all know that the minimum number of colors we use for graph coloring. Now coloring algorithms. So we basically have so many algorithms in graph coloring. Some of the major algorithms that we can use in the graph coloring are greedy algorithm, backtracking, and Welch-Powell algorithm, Dastor algorithm. So basically these four are the main algorithms that we use in graph coloring. Let us uh, let us discuss briefly about these algorithms. So first, greedy algorithm, this basically assigns colors one by one, selecting the lowest available color for each vertex. And then when we look at the backtracking, it actually explores all possible color combinations and then colors the vertices. And when we come to the Welch-Powell algorithm, this is basically a new algorithm that we heard up to now. So this basically orders vertices by degrees and then colors them. Next we have Dastar algorithm. So here it prioritizes vertices based on the saturation of their adjacent vertices. So we can choose any one of the algorithm, depends on the graph size, structure, and the number of colors needed. Now number. So what is a chromatic number? So we have already heard this term in our previous slides. Let us get to know the depth of this chromatic number. So the chromatic number is minimum number of colors needed to color a graph. So basically when we consider a graph, here in the diagram I have given few graphs. So let us consider the first graph that we have three vertices, and here these three vertices are can be colored with three colors. But there are some, like when you look at the third example, that is the third diagram in the presentation, we have five vertices, and here we have used only three colors. So basically the graph is with 5 vertices, but we have used only 3 colors. So this minimum number of colors is known as chromatic number. Next, let's look at the applications of graph coloring. So I have already mentioned that we can use graph coloring in various applications. First we have scheduling, register allocation, map coloring, networking, resource allocation. So these are the major applications where we can use graph coloring. And now example problem. So to get better understanding of how this graph coloring basically works or colors a graph, let us take an example of a graph with 4 vertices arranged in a square shape. So basically we start with the first vertex and assign color 1 to the vertex, and then we'll move to the next vertex and assign the lowest available color not used by the adjacent vertices. So these are the statements that we use to explain how the graph coloring is done. But let us see how it is done. So first we considered the graph with 4 vertices. So I have taken the graph vertices as A, B, C, D, and there is a statement in graph coloring that if the degree of graph is n, then n plus 1 number of colors are used in graph coloring. So basically here I have given a graph with 4 vertices, right? So the degree of the graph, how we can find out the degree of graph? We all know that the degree of graph is based on the incoming and outgoing edges. So here, since it is a square shape, we have every vertex has a degree of 2. So the highest degree of the graph is on 2 only. Since the graph degree is 2, then n plus 1 number of colors, which means 2 plus 1, 3 colors are used in graph coloring. I mean the 3 colors are used for coloring this graph with 4 vertices. Now let me give how this graph coloring is basically done. So I have taken a graph with 4 vertices, and here I have color 1 as blue, color 2 as green, and color 3 as violet. So let me consider this first vertices, that is the vertex A is filled with color blue. So consider this vertex is filled with the blue. Then the second vertex, we have two choices for filling the second vertex. It either can be blue or it can be violet. So we basically have two choices, right? Since we have filled the first vertex with blue color, we cannot fill the second vertex with the same color, since the graph coloring rule states that no two adjacent vertices should have same color. So we fill the first vertex with the blue, then we have two choices for the second vertex, that is green or violet. Next, when we look at the third vertex, this third vertex can be either again filled in two choices. So it can be filled in violet, blue, and based on the second vertex coloring, if we have taken the second vertex as green, then we can here the third vertex can be filled with violet, or else if we have taken the color violet in the above second vertex, then the third vertex can be filled with green. So likewise we had three choices for the first vertex, then we had two choices for the second vertex, and again we had three choices for the third vertex. Similarly, when we look at the fourth vertex, if we have filled the first vertex with the blue and second vertex with the green and third vertex with either violet or blue, then we can fill here with the green. Or else if we have filled the first vertex with the blue, second vertex with violet, and the third vertex with either green or blue, we can fill here either violet or we can fill either violet or green. So likewise, we have many number of possible choices that we can color this graph. So let us look at the choices that we have for coloring a graph with 4 vertices. So here basically x1, x2, x3, x4, these basically represents the vertices in the graph, and this 1, 2, 3, these are the colors that we have used in the coloring. So this is the overall state space tree of the graph coloring of 4 vertices. So basically, if we have taken the vertex 1 as we can take the vertex 1, I mean we can color the vertex 1 with either 1, 2, 3 colors, and if we have colored with 1, then the second vertex either colored with second color or third color as I mentioned earlier. So if we consider the second vertex is colored as second 2, then the third vertex can be colored as 1 or 3. Then if we consider the first vertex as 1, second vertex as 2 and the third vertex as 1, then the fourth vertex can be colored in two ways. So likewise we have this many possible choices that we can color a graph with four vertices. So the solutions basically we take the solution set as 1, 2, 1, 2. That means in the state space tree we take the vertices like here x1 equals to 1, x2 equals to 2, x3 equals to 1 and x4 equals to 2, right? So we basically take this as a set, that means 1, 2, 1, 2. So similarly we take all the possible choices that we have in the state space tree and write the solutions. So here we have so many solutions. We have 18 solutions for the four vertices graph. So likewise, we can color a graph which has 8 vertices, 9 vertices, 10 vertices, and so on. But the solutions might increase a lot. But we can color a graph with n number of vertices by using n plus 1 number of colors, and this minimum number of colors is known as chromatic number. So this is what we have learned up to now, and this is what a graph coloring basically is. And I hope everyone has understand at least a little bit about what is a graph coloring. Thank you all for listening.